Hi folks, welcome to another Wednesday Widget by PCNC. Today, I want to talk about thread milling. I think thread milling is really cool. I'd wanted to get into it. I did a tutorial some time ago. You can see a little video screenshot here of thread milling a buffer tube nut for an AR-15, and that was great, and I think it was a decent video, but I hadn't thread milled much since then, and I wanted to relearn how to do it, and I went and watched my video, and frankly, I didn't think that tutorial was as good as it should have been. Tormach also has a few tutorials, and I love the guys at Tormach, and Eric, who I think actually just moved out west to take a new teaching position. He used to handle all of their SprutCAM stuff. Is a great guy, but frankly, it's a long video that doesn't cut to the chase. So here's what we're going to do. I'm going to show you in as short a time as possible. I'm hoping 2 or 3 minutes, just how easy it is in SprutCAM to create not only the thread milling operation, but the correct tooling on a multi-flute, or what do you call it, a multi-length thread mill versus a single point thread mill, to render it in the simulation. We're going to hop over to Tormach. We're going to machine some fixtures and some brackets that I use for our rimfire steel targets that we sell and make here in the shop here in Zanesville, Ohio. And then after all that, I'll talk a little bit about thread milling and the process behind it and how it compares with tapping and the merits and so forth. But I'll save that talking stuff for the end so that we can dive right in. So let's hop over to SprutCAM. Here is the tool we're going to be working with in SprutCAM. Lakeshore Carbide 5/16 by 18 thread mill. And as you can see, this is got about 3/4 inch of thread cutting. So unlike the last tutorial I did with a single point, this is going to be a little bit different and a little bit cooler in my opinion. So now you've got an idea of what we're working with. Let's hop into Sprut. Okay, in SprutCAM I've got a part. You need to create a drilling op before we do the thread mill, of course, for your clearance hole. We will go into Create Roughing Hole Machining 5D. Now we'll go ahead and select the center of that to start with and hop into this. Now, first things first, don't choose threading mill, choose limited conical mill. We'll call it 5/16 by 18 thread mill. Tool number for me, 222, whatever you want to pick. Length is going to be 1 divided by 18. That's the threads per inch divided by 2. The thought there, or the logic there, is that you're choosing the height, half the height of one of the cutting edges of the tool. And it's an 18 threads per inch end mill, or thread mill rather, and you want to just model, for the cutting tool, we're going to model the rising bottom edge. So that's half of one cutting edge. Diameter, we know from the Lakeshore Carbide website that the cutting diameter of this tool is 240. So 0.24. Threading is 60 degrees, and the height of the tool will be the same thing as the length, 1 divided by 18 divided by 2. And if we zoom in, I don't know why, but we're going to get a little error here. Delete the overhang to try to get rid of this gray white stuff. Come out of this window, come back, and then now for some reason you can delete this and we get what we're looking for. And if we zoom back in on the tool here, you can see roughly that will represent the bottom edge of the tool itself. Now we've got the correct cutting tool, and this is all you actually would need to do to correctly get G-code that will work, but I want to render the whole tool so that we can see it simulate in SprutCAM. And so the way we do that is we create the rest of the cutting tool as a holder. I think this is a little bit cumbersome, but the truth is it works, and you guys will see hopefully here it's not that hard. So what we want to do is we want to alternate between the inside diameter and the outside diameter going up in increments of the height itself. So all you got to do is type in 0.144, that's the inside diameter, and then colon 0.0277, that's the height. So now we're to here, and we type in semicolon to start a new one, and 0.24, which is the OD, colon 0.0277, and you see now we've come out to here, and all you actually have to do is copy and paste that a whole bunch. So I've got a string here ready. This is again on the NYC CNC website. If you're doing a 5/16 by 18, otherwise just retype it yourself. And I paste this long string in here, and you can see that gives us our tool. Obviously it doesn't have the flutes cut into it, but you get the idea. Now, the only problem is that we need to put all this gray stuff above the cutting tool itself, and you do that by adjusting the overhang. Now, in theory, you're supposed to be able to create the overhang by adding up all of the heights that we've created here, so all the 0.277s. For some reason, I've had trouble with that, so I actually just eyeball it. It really won't matter, again, for how you actually cut. So I calculate 0.6648, or rather estimate, and if you zoom in here, you can see that is pretty darn close. If we just add, if we go to add 1,000 to 5.8, you can see we're off, and if you go to 3.8, we're below. So I wish I had a better answer for you there, but again, it's not actually critical to the G code itself. So now we've got our tool. Fees and speeds, I'll leave up to you guys. And strategy, okay. We will change to bi-spiral thread milling, longhand, ID, bottom up, that's my preference. You could do top down. Spiral direction is right. Thread depth, this is a distance, and we will calculate this by going to a drill tap chart, and I have to laugh. Tell me if anyone else has Googled, finds this as this page as the first result, and always uses it. Major diameter, you can see up here in the headers, is 3125. Minor is 2443, so 0.3125, 0.2443 minus 2 divided by is 341. So 0.0341. I'll come back to what that actually does in a second. Spiral step, that's simple, 1 divided by 18 because 18 threads per inch. And the next thing we got to do is we're going to rough it in 2 passes. Now, if you just create the code here, it will assume you need to spiral thread through the whole hole. We don't have to do that because we have a thread mill that is not single point, but rather has length to it. So we only need to really do 1 rotation. So what we'll do here is change this to axial divide, turn count 1, and what we can do is say this tool is, if we want to get specific here, the cutting length I think is 625, so 0.625, and if we render that now, you'll see we're only coming up a little bit more than 1 rotation. And to make it even cleaner, I'll turn off the roughing path. So it cuts it in 1 pass, and you can see it would ramp, go all the way to the bottom here at about about 11:30, come in, wrap all the way around, come back to 9 o'clock, ramp out. And now, if we render that, turn the other one off, preview our drill, and hit play, you can see we've got enough hole clearance, barely, coming down, and it's going to go all the way down to the bottom. And this is, again, doing it in 1 pass. Voila. Now, I will say it seems to render much cleaner when you only have 1 pass. So if you try to render it with multiple passes, it kind of doesn't look as nice. It doesn't actually change anything, just a heads up. And then the only thing I wanted to add is the thread depth. As best I can tell, all that does is changes when you rough it, the roughing steps. In other words, it doesn't affect the thread engagement or the thread tightness or gauge, whatever you call the thread fit, but rather if you were taking it in 3 or 4 passes, that is, it determines how far in to come on the thread depth as to what to make that. So in other words, you can basically change the thread depth to whatever you want to rough out in smaller increments or bigger increments, or you could take it to 0, or if you have it thread milling in 1 pass, I believe that number is irrelevant. I'll take some safe heights here to 0.1 just to be safe, and we're good. Okay, so fast forwarding here while we run through the other ops, spotting, drilling, so forth on these parts here. This is a side note, a great example of sort of how I work, which is 6-9 months ago when we were going through different iterations and improvements on these little rimfire steel targets. This was the fixture I came up with for these brackets. It's super simple, just a set of reamed holes and very simple strap down clamps, and it works, but you can see this only runs 12 at a time, and it's an aluminum fixture. So time to improve this. We make enough of these things now where I need something bigger and more rugged. So you'll probably see an upcoming video here on improving that. So hopefully here in the next few weeks you'll see a new video on improving this fixture, making a bigger one out of steel. Something I'm anxious to do, but I haven't done it yet because there are more pressing things to get to. And while I don't love this one, it does work, and we're able to keep up, although maybe a little bit inefficiently, getting these things out the door. Okay, haven't touched the parts yet. We're fresh off the mill. Grab our shoulder bolt here. And it's always tricky with the camera in there. And that's why I think thread milling is so cool. That's almost too tight. Get the hex key in there. Beautiful fit. Much firmer fit, if that's what you're looking for, than with a tap. Now you can buy different types of taps and so forth, but this is easily customizable. And in fact, before we go any further, let's hop back over into Sprut here and I'll show you how you can adjust, or how I have found that you can adjust the diameter of that thread engagement, which controls how tight the thread fit is. The way I adjust this, and there may be other ways, is I actually change the diameter of the hole itself, which if you've used SprutCAM much, you know you don't actually have to use the solid model geometry, but rather can override it here. And that would be a 5/16 hole, which would be 3125, and you can see I've already added 1/1000th by changing it to 3135. And if you made it even bigger, it'll increase that toolpath. I'll show you real quick. What we'll do, we'll turn off the model, and we'll cheat here, or do a silly way of doing this, which is I'll line up the blue edges with the model. Go in here and I'll just change the I'll just change the first one to let's make it smaller just for the example's sake. We'll make it to 0.30. Click OK, click run, and you can see it's smaller. And go back to 31 45, which would be a thou bigger than we had it before, and you can see it's just a hair wider. So that's the way I have found to reliably adjust your thread engagement, your thread fit. And it works great. I'm happy with it. So let's talk a little bit about thread mills and what their merits are and why you should stay away from them. So is thread milling good for you? Well, what I did is I made a list of all the things I could think of, and then I went online and Googled and looked at some threads on Practical Machinist and CNC Zone, and there's some links to those on the NYC CNC webpage. Absolutely don't want to not give credit for those. First off, they're not cheap. It's a $67 tool, and not only is that expensive as an investment, but if you break the thing, that is not fun. But I don't think that's reason alone to come close to writing it off. The consensus online seems to be small holes, maybe ½ inch or smaller, you want to tap, or you're better off tapping for time and cost, and bigger holes you definitely want a thread mill. Rather than get into the opinion of what's better, let me just talk through my little list of things I could think of. First of all, I'm using a solid carbide thread mill, and you can buy insert style thread mills where you're not having to spend so much money on a solid piece of carbide, but rather an insert that you can replace, and I assume also very easily change the thread pitch, which is key. You can cut outside diameter threads with the same tool. We're back, by the way, to even the thread mill that I have today. You can cut OD and ID threads with the same tool. That's pretty cool. That's called a 5/16 by 18 thread mill, but the truth is that it's really just an 18 pitch thread mill. So you can cut anything that's 18 thread. The only restriction would be for the ID has to be, the hole has to be big enough for the tool to fit inside of it. And then for the OD, I've only got so much root pitch or minor to major diameter of cutting power in that tool. If you break a thread mill in a part, it's a different type of breaking versus when you break a tap. So you may actually be better off if you break a thread mill or snap one off, maybe a better chance that you can get it out or change it. You may still have rolled the part versus when you break a tap in a part, unless you're going to have it burned out or EDM'd or whatever, it's not good. You can go all the way down to a bottoming hole. So you can thread reliably to on a non-through hole or blind hole, couldn't think of it for a second. You can get the threads all the way down to the bottom. Apparently this is a big deal in aerospace, definitely not what I do. But with the Tormach style head, it's a tension compression head, so you don't have that level of precision in the Z. And I've never used a rigid tapping machine, but I would think you'd still be hard pressed to go all the way but down. Not to mention even a bottoming tap won't thread all the way as low as these guys can. These are not right or left hand dependent, so we could cut left hand threads with the same tool as right hand threads, if that's your thing. You can cut it in multiple passes. This is one of the biggest things that I think is great, is as you saw, we can cut one thread in 1, 2, 3, 4, or 20 passes of depth. So you're not limited to your machine's power, or nor are you having to take this huge cut in one pass. When you're using a standard tap, even if it's a spiral point or spiral flute tap, you've still, on a machine like the Tormach in most mills, you've got to go at it in one fell swoop. Some rigid tapping machines, as I understand it, have positional accuracy so that they can tap partway down, come back out, finish tapping. Still, not nearly the level of ability to tackle either hard materials or gummy materials like you can with a thread mill. And because the thread mill is narrower, the diameter is smaller than the hole you're cutting in, you've got a much better path to evacuate chips. So that's huge, because anybody who knows, who does a lot of tapping, the biggest problem a lot of times is chip buildup. I also like it better for coolant. I don't like cutting or running taps without putting a little bit of manual coolant on there. Now I also run a misting or micro drop system, and sometimes I don't think it gets quite enough lubricant or coolant as lubricant on a tap, and that's specific to my system. If you're using flood coolant like I think most people are, you may be okay with that. But I like this because I'm totally fine running it with the micro drip system I've got. Let's see what else. Obviously, big threads, anytime you're running a big diameter tool slowly, takes a huge amount of torque, usually at low RPM, and that's not something that's always common, or certainly not cheap feature to have. Thread mills make that a totally moot point. You can be thread milling a 2-inch hole at 2, 3, 4, 5,000 RPMs, whatever pass you want to take. Let's see here. I talked about the chip evacuation. The fit of the threads we already talked about. I think it's really cool. You can have a darn near tight fit, like really tight fit, or you can have a much looser fit. Whatever you want, you decide. I don't do this, but you can wrap it out of the hole. So when it comes to really optimizing cutting time, you can wrap it in, make your cut at your cut feed, and then wrap it out and up out of the part. When I was researching it, folks said that thread milling is slower. What I found is that thread milling is actually faster. That cycle that we just ran there is about 7 minutes and 33 seconds with a tap, and it's about 6 minutes and 50 seconds with the thread mill in 2 passes. Doing the thread milling in 1 pass would shave off another 20 seconds. I don't know that that's common, and I was speculating why would it be different, and it must be because I tap relatively slowly, 400 or so RPMs and a relatively slow feed rate, and then obviously you have to go out at a slow feed rate as well. So that's, I guess, why it's faster. You can use the same thread mill for all different types of materials, which is nice. It doesn't, it may work for plastic to aluminum to steel, etc. It does, I guess, on a downside, require an expensive machine that can do helical interpretation, i.e. any CNC machine. I don't really think that that's a big deal these days, but you can tap on a dumb machine, a drill press, or a Bridgeport with power tapping, or a Procunior tapping head, that type of thing. Oh, this is really cool. I've not seen one of these, but it makes sense that they have thread mills that below the thread mill portion of the tool have a drill bit. So you can actually use the same tool to drill down, and then once it's drilled through, it continues further down and thread mills in 1 pass. So that's a big deal. When guys are running parts, you have less tool change, you have 1 less tool holder taking up in your auto tool change carousel. Pretty cool stuff. Obviously wouldn't work for blind hole, but through holes all day long. And yeah, I guess that's it. So hopefully you've learned something today. I mostly wanted to emphasize that it is not difficult, despite it being seeming cumbersome, and I don't think there are other good tutorials out there on how to do it. It is easy to thread mill in SprutCAM. It's easy to thread mill on the Tormach. The last thing I'll say, because I know you guys are going to say it in the comments below, is it's easy to write this G-code by hand. Maybe we'll do that in another tutorial. And there are also some, I think they're the newfangled wizards in Mach 3 that make it easy as well. That's not my thing. I like SprutCAM. It's just my go-to option. So that's what I wanted to cover today. But I appreciate it, folks. Hope you guys enjoyed this. As always, I appreciate the likes, the thumbs up, the comments, the shares. I will see you guys soon. Take care.